Hi, here's our question on indices. We're asked to evaluate this without the use of a calculator. So, first of all, let's rewrite this. 4 squared is actually 16, and if we're raising something to a negative index, we can just write it as the inverse, so that'll be 1 over 16, and this is actually the fourth root of 1 over 16. So we can rewrite this as 1 over 16, and we take in the fourth root. And 9 raised to the power of 3 over 2 is the same as 9, the square root of 9, and we'll cube that. And our denominator, we can simplify. This is like taking the square root of a quarter. It is, in fact, taking the square root of a quarter. We'll take the square root of 1, which is 1, and the square root of 4, which is 2. So this evaluates to a half. Our next step is to evaluate what is the fourth root of 16. We know the fourth root of 1 is 1. The fourth root of 16 is 2, because 2 times 2 times 2 times 2 is equal to 16. So this evaluates to a half in the numerator. We know the square root of 9 is 3, and if we cube that, we get 27. And this is all divided by a half. This cancels with this to give us 27. Just to recap, we clear the brackets here using the law of indices by multiplying first what's in the brackets to get 16, and then taking the fourth root. We invert 16 so that we can have a positive index of a quarter instead of minus a quarter. Here we separate 9 to 3 over 2 as 9 to the half, and then that's cubed. Making it a lot easier to evaluate, and in the denominator we're taking the square root of a quarter. In fractions you take the square root of the numerator and also the square root of the denominator. This half, or this square root, applies to both numerator and the denominator. And that gives you a half. Cancels with a half from this expression, and we're left with 27. And here's another question on indices. We'll clear the brackets here to give us 5 to the 6th power times 5 to the 5 over 6. And like before, we have a negative index, so we can take the inverse of 4, which is 1 over 4, and now we can apply the index of a positive index now to both numerator and denominator. This we can simplify further. We have the same base of 5, so now we can write the base 5 and add the indices, and that gives us 6 over 6, which is 1. 5 to raise to the 1 is 5, so we can leave that like that. And in the denominator we have the square root of 1 is 1, square root of 4 is 2, so it's 5 divided by a half, which evaluates to 10. So, just to recap, we clear the brackets. Because we have the same base of 5, we can add the indices, and that gives us a whole number, 5 raised to the 1, which is 5. In the denominator, we want to evaluate a positive index, so we take the inverse of 4, which is a quarter, and now we have a positive index, which is to raise a quarter to the half, which means taking the square root of both the numerator and denominator, and that gives you a half. So we have 5 divided by a half, it gives us 10. And that's it. My name is Alistair. If you have any questions or comments, please send them to me. Don't forget to like, follow, or subscribe for more videos like this. Thank you. Bye for now. Hi. Here we have a function f of x, and we're asked to find f of half x. Now, key to being able to tackle a problem like this is to understand function notation. What this means is that there's a function of x. X is the input, and whenever you get the input, the rule is that you multiply its value by, you square it, then you multiply it by 4, you multiply it by 3, you sum that with -2, and you have the result. So let's do that for the input, a half x, or x over 2. So we have 4 times the input squared, x over 2 squared, add 3 times x over 2, take away 2. This gives us 4, this is x squared over 4, add 3x over 2 minus 2. Which gives us, this cancels with this, give us x squared add 3x over 2 minus 2. Now we can simplify this just a step further by creating a common denominator for each one of these. If we multiply across here, we have 2x squared, we have 3x, we'll have the denominator of 2, and this we multiply by 2 to get 4, and our common denominator is 2. If you were to simplify this by dividing each term here by 2, you would get back to this step. So this is the simplest form of our result. Then we have a different input. Our input now is 3x add 2. The function is still the same. Let's go ahead and evaluate this. So we have 3x add 2 is equal to 4. We want to square the input. Multiply by 3 and add -2. This evaluates to this squared, which is 9x squared, add twice the product of 3x and 2, which is 12x squared to 2. And then we have 9x add 6 minus 2. Now we have 36x squared add 48x add 16 add 9x, and this is 4. This gives us 36x squared. 48 add 9 is 57x add 20. And that's the simplest form of our result. Again, the function notation f of x, input, whatever input you have, you must follow this rule. 4x squared add 3x minus 2. Our input is 3x add 2, and so I substitute wherever x is, I substitute 3x add 2. I evaluate that and simplify it. And that's it. Thanks for watching this video. My name is Alistair. Any questions or comments are welcome. Please like, follow, or subscribe for more videos like this. Thanks and bye for now. Suppose we have this fraction and we wanted to simplify it or find the value of it, and we didn't have a calculator. Well, here's a quick way of manipulating both positive and negative indices without the use of a calculator. We'll try and keep everything positive, so we'll have the 2 to the 3rd power there. And in the denominator, we'll still have 4 squared, but we'll move the 3 raised to the negative 2 in the denominator, and that becomes 3 squared. And also the 5 raised to negative 1, that becomes just 5. And instead of having this as a negative, with a negative index in the denominator, we'll move this to the numerator, and it becomes 0.3 squared. So just to recap, we're moving the negative indices into the denominator and they become positive, and if we have any negative indices in the denominator and we move it to the numerator, it becomes positive. So we have 3 to the negative 2 becomes 3 squared, 5 to the minus 1 becomes 5, or 5 to the 1, 1st power, same thing, and 0.3 to negative 2 in the denominator becomes 0.3 squared in the numerator. And now we can go ahead and simplify this. This is 2 to the 3rd power is 8. Now this 0.3 squared is 0.09. And we have 16, 4 squared, we have 9, and we have 5. Now let's rewrite that here. We have 8 in the numerator, 0.09 over 16 times 9 times 5. Now 16 5s are 80, 80 times 9, we have 720 in the denominator. And 8 times 0.09 will give us 0.72. And further to this, 0.72 is the same as 72 over 100, and that's in the numerator. Now it's 720 over 1 in the denominator. We make that 1 over 720 and multiply it by 72 over 100. Now we can cancel or simplify in this direction. This gives us 10. And now we're left with 1 over 100 times 10, which is 1 over 1,000. Now there are two ways we can express this result. Well, three ways. We have 1,000th. We could also express it as 0.001, or in standard form as 1 times 10 to the minus 3. So all three of these, this, and this, are equivalent. Thanks for watching this video. My name is Alistair. Any questions are welcome. Please like, follow and subscribe for more videos like this. Bye for now.